The given point lies on the terminal side of the angle theta in standard position. Let's talk about standard position very quickly. That means the initial side of the angle is on the positive x-axis, and then we open up the angle to whatever in a counterclockwise direction. That'd be positive. And then find the values of the 6 trig functions of theta. So we're going to draw the xy axes. We're going to put this point on the xy plane. We have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So negative 6, 6. I like starting out with this one because, well, we have this angle right there. That's the angle that we're really trying to find information about. But we're going to use the acute angle to get all the information about the big angle. And to get the acute angle, we go to the closest x-axis, which would be this one, and we draw a triangle. So we're going to use information about what we call a reference angle to find out information about the big angle. Now, because this is negative 6 and that side's 6, I happen to know what the little angle is. Do you know what it is? Yeah, it's 45 degree 90 right triangle, right? So this one I just happen to know because I know if they're the same, it's got to be a square. We are asked, well, if this is negative square root of 6 and that's 6, what's the hypotenuse just from what you know about that special right triangle? What is it? 6 square root of 2, right? It's 6 square root of 2. Now you can do Pythagorean theorem and get that 6 square root of 2. It'll be the same thing. We have sine, cosine, tangent. We have cosecant, secant, and cotangent. Well, now to get the sine of this 135 degree angle, I just happen to know what this one is. You don't need to know that, not for this problem, because I know the sine is opposite over hypotenuse. And you've kind of already done this. Even on your quiz, you did this to some extent, without the 6's, of course. Cosine is adjacent over hypotenuse, but now, not because we're on the xy axes, we have negatives. Not everything is now not positive. So we have negative 6 over 6 square root of 2, which is negative square root of 2 over 2. That's why the sine of 45 degrees is square root of 2 over 2, no matter what the length of the triangle is. It can be anything. It's going to work out. And then the tangent is 6 over negative 6, which is negative 1. So now we have, this is square root of 2, this is negative square root of 2, and this is going to be still negative 1. The reciprocal of negative 1 is negative 1. Questions on that one? All right, find some white space. I'm just going to delete that. Just find some white space on your paper. We got 5, negative 3. 1, 2, 3, 4, 5. 1, 2, 3. I don't know what this angle is. 5, negative 3 is nothing special. It's some angle. But really, we're trying to find out the information about that angle right there. That one all the way around. We use the acute angle to do that. And then we draw the triangle to the closest x-axis, always to the closest. This value is 5. This is negative 3. Now we have our normal right triangle, just one of the values happens to be negative. We have 25 plus 9, that's square root of 34. Square root of 34 using Pythagorean theorem is the radius of a circle that I could draw going around, or the hypotenuse. Sine, cosine. Once you set it up, I think it's pretty straightforward as long as you know that SOHCAHTOA deal, right? Cosecant, secant, cotangent. Now, if we're using this little acute angle in here, we have opposite over hypotenuse. That's going to be negative 3 square root of 34 over 34 if we rationalize. Cosine is adjacent over hypotenuse. 5 square root of 34 over 34. Tangent is negative 3/5. That means cotangent is negative 5/3. Secant is square root of 34 over 5. Which one's the negative one? The sine right here. So This is square root of 34 over 3, but negative. So it's all in the setup. I think if you can get it set up, these aren't really that bad. Questions on these two? Find the exact value of each trig function, if defined. If not defined, write undefined. So trying to find the trig values of, what about points that lie on the x or the y axis? What if we wanted the tangent of 2 pi? 2 pi is all the way around, right there. There's 2 pi. So we're doing this with triangles. So we have to come up with a triangle with this. But one of the sides happens to be 0. And if one of the sides is 0, you don't really have a triangle. But let's say we did. Let's say we had this triangle that's getting closer and closer to 2 pi. And as you get closer to 2 pi, this opposite side, if that's a little acute angle right there, that opposite side is getting closer and closer to 0, and eventually it will be 0. This adjacent side is working its way out to 1, so this side is 1. And you're like, wait a minute, you don't have a triangle if you have one of the sides is 0. That's okay, let's pretend we do. So the tangent of 2 pi is opposite over adjacent, which in this case would be 0 over 1. 0. Grab your calculators. Mode, we are actually working with radians for this problem. So I'll put my calculator in radians. And like I said, if you have to hit sine, cosine, or tangent button, radians matters. If you don't hit those buttons, it doesn't matter. All right, so how about the tangent of 2 pi? 0 is 0. If we did the cotangent of 2 pi, it would be adjacent over adjacent over opposite. Even though the opposite side's 0, we pretend that we have this triangle here, which would be 1 over 0, which is undefined. So if we take 1 divided by the tangent of 2 pi, your calculator screams at you. Error! Division by 0. Yeah, division by 0. 1 over 0. So it tells you. It's like, there's no value there. It's undefined. Cosecant of, erase. There we go. Cosecant of 270. What if we draw a triangle or an angle really close to 270 and then take it to the nearest x-axis right there? This side is getting dangerously close to 0. And the length of the opposite side is getting really close to being not 1, but rather negative 1, because we're going down. So cosecant is a reciprocal of sine. Sine, oh, by the way, the hypotenuse is always 1. Hypotenuse is always 1. This is called the unit circle. 1 unit. So the radius is always 1. Sine would be opposite over hypotenuse, or negative 1 over 1. So cosecant is 1 over negative 1, but either way, it's going to be negative 1. Mode, whoop, get out of that. Okay, quit. There we go. Clear. Mode. Degrees. We're not going to do this for every single one of them, but 1 divided by sine of 270. I'm saying it's negative 1. Negative 1. There you go. Secant of 180, or pi, either way, but it's 180 right now. 180 is right there. How about a triangle? How about an angle that's getting really close to 180? This is the side that's getting closer to 0. This hypotenuse is 1. This is getting close to being negative 1. Secant of 180 is the reciprocal of cosine, which would be 1 over negative 1. This one happens to be negative 1 as well. Secant of negative pi over 2, that's down here. So 270 and negative pi over 2, they're coterminal. They're the same thing. Just go the different direction. So this is the one that would be 0. This would be getting closer to negative 1, and the hypotenuse is 1. Secant is the reciprocal of cosine, which would be adjacent over hypotenuse. No, that's cosine. So it'd be hypotenuse over adjacent. Hypotenuse over adjacent. That's undefined. But I'm going to give you, before we leave today, I'll give you a better way to get that, because I have to cover tomorrow's material a little bit for you. Sketch each angle, then find its reference angle. Here's 18. 210 degrees is 30 past 180. So that's how you draw an angle on the unit circle. So that's 210 degrees. The reference angle is how far away the closest x-axis is. The closest x-axis is right there, and it is merely 30 degrees away. There's its reference angle. And the reference angle is always reported as a positive value, never negative. 11 pi over 3. Pi is 3 pi over 3. So there's 3 pi over 3, 6 pi over 3, 9 pi over 3. I need to go 2 more. There's 1 pi over 3, 2 more pi over 3s. There's right there, because there's 1 right there. So this right here is 11 pi over 3. You guys get that? You okay with that? Then the reference angle is how much farther would I have to go to get to the closest x-axis. I'd have to go 1 more pi over 3 to get to the x-axis. So this reference angle is pi over 3. Anytime you're given an acute angle, it's really its own reference angle. But negative 75 degrees, you go backwards. So roughly, I don't know, about right there, don't you think? About right there. That's close. There's negative 75 degrees, and its reference angle is 75 degrees. You'd have to go back 75 degrees to get to the closest x-axis. It's always reported as a positive value. Any questions? Cool. All right, that's today. Since I'll be gone tomorrow, give me about 10 more minutes, and then I'll let you work on your homework. Give me 10 more minutes. Let me get you set up for tomorrow. That way my absence will be a little less detrimental to your grade. Hopefully not at all. Unit circle. Here we go. I love this stuff. This is one of my favorite lessons of all times. I really was upset that I'm going to be gone tomorrow. I really was. But I'll give you the short version right here. Let's start with pi over 6, and we'll work our way around the circle. Pi over 6, that's the same as 30 degrees. Same thing. One's radians, one's degrees. That puts the 30 right there. Or the pi over 6. Same thing. And then if you drop that side down to the closest x-axis, then this now is 60 degrees. There's our 30, 60, 90. That's why pi over 6 is a radian that interests us. If the radius is 1, remember that comes from an equilateral triangle, what is that side? Half, right? That's the half. And what's this one, which would have been our height? What's that side? You remember from your quiz, right? Square root of 3 over 2? Square root of 3 over 2. All right, so what? There's a big so what right here. That point right there on the unit circle is the point square root of 3 over 2, 1/2. Square root of 3 over 2, 1/2. That's that point. I mean, follow the x. Follow the x. Square root of 3 over 2, 1/2, right? That's how you find points. But there's someone somewhere along the way, way back, 500 years ago, 200 years ago or whatever, said, well, wait a minute. The sine of 30 degrees is opposite over hypotenuse, which is also a half. Then they went, well, wait a minute. The cosine of 30 degrees is adjacent over hypotenuse, which is square root of 3 over 2 over 1. That's square root of 3 over 2. This value is the cosine of pi over 6. This is the sine of pi over 6. So having the x and the y, the coordinates, having the coordinates, is exactly the same as having the cosine value and the sine value. Here, grab your calculators. Put them in, is it still in radian? I'm telling you that the ordered pairs is cosine of theta, sine of theta. So let's take the sine of pi divided by 6. When I hit enter, it's going to say 1/2. Square root of 3. Yeah, square root of 3. Ah, I hit the divide sign too soon. Divided by 2 is the decimal value, 0.866. If I hit cosine of pi divided by, not 3, I don't know why I got 3 on my mind, 6. There, square root of 3 over 2, 0.866. See, it's the x coordinate, it's the y coordinate, cosine, sine. No applause? All right, fine, be that way. I'm just kidding. Just one day, just one time, maybe. It's never happened. How about pi over 4? Let's get a new circle, right? Draw a new circle. This is going to get too messy if I try to do everything in one shot here. Pi over 4. We're going to try to find the x-coordinate and the y-coordinate so that we know what the cosine of pi over 4 is and the sine of pi over 4 is, because they're the exact same thing. It's awesome. We drop that down. We know if this side is 1 and that side's 1, then this side is 1 times the square root of 2. But that's kind of messed up for our unit circle because it's the hypotenuse that's 1. It's the radius that's 1. So what if we divided everybody by square root of 2? Now we've made the radius 1, which is what we want when we're on the unit circle. So if we rationalize, it's square root of 2 over 2, square root of 2 over 2. Cosine of pi divided by 4. I'm not going to do this for every single one of them. Square root of 2. Where's square root? It's hard to see. Oh. Square root of 2 divided by 2. It's the same answer, 0.707. All right, but I forgot to do it on the other one. But now, over here, at 3 pi over 4, it's going to be negative square root of 2 over 2, square root of 2 over 2. It's the x value that's negative, right, in the second quadrant. X that's negative. Down here, 4 pi over 4, 5 pi over 4. Negative square root of 2 over 2, negative square root of 2 over 2. It's all the same. All you got to do is know the first quadrant and you know all of them. Just you got to know where to put the negatives. This is 7 pi over 4. It's square root of 2 over 2, negative square root of 2 over 2. We do pi over 6s, we do pi over 4s, and we do pi over 3s. So we got to do one more. We're almost done. One more circle. Pi over 3. Or 60 degrees. See, that's why we do the other one, because this is the 30. Down here is the 60, or the pi over 3. So it's just flip-flop from the 30-degree angle. And we know values for this. This is the 1/2. This is the square root of 3 over 2. That's the 1. So now it's 1/2 square root of 3 over 2. So what is the cosine of pi divided by 3? It's 1/2. 1/2. Now you know 3 more. 2 pi over 3 is negative 1/2 square root of 3 over 2. Down here, that's 3 pi over 3, 4 pi over 3 is negative 1/2 negative square root of 3 over 2. Everybody's negative in the third quadrant. Both of them. Not everybody. And then this one is 5 pi over 3, right? 1, 2, 3, 4, 5. Yep. That's 1/2 negative square root of 3 over 2. Now with the pi over 6s, I forgot to do that. Here's pi over 6, or 30 degrees. It's square root of 3 over 2, 1/2. Over here is 5 pi over 6. That's negative square root of 3 over 2, 1/2. Always try to find the 1/2. If this right here is the longer one, that's the square root of 3 over 2. If this is the shorter one, that's the 1/2. It's actually, and then on the pi over 3's, this is the shorter one right here. That's the 1/2. This is the longer one. That's square root of 3 over 2. You'll see on the video, I always try to find the 1/2. Where's the 1/2? 7 pi over 6. That's negative square root of 3 over 2, negative 1/2. And then the last pi over 6 is over here, 11 pi over 6. That's square root of 3 over 2, negative 1/2. So you should know all the pi over 6's, all the pi over 3's, all the pi over 4's. And you'll have to know all the pi over 2's. That one's really easy. By the way, that'll make your homework a lot easier. We already did the pi over 2's. That point right there is 1, 0. This is 0, 1. This is negative 1. This is the easiest ones of them all. Negative 1, 0, excuse me. 0, negative 1. So what's the cosine of 0? 1. What's the cosine of pi? Negative 1. Remember, as a reminder, it's cosine, sine. Always cosine, sine. X value is the same as the sine of the angle. The y value is always the same as the sine of the angle. All right, that'll give you a head start on tomorrow. I got a couple things for you, though. Well, I got this in the quiz. That would make it a couple things. This is a reference sheet of pretty much everything we're going to do as far as trigonometry. We do some other things this semester also. It's not all trig. You're welcome. Oh, I just have exactly enough. I was a little worried. There you go. You're welcome. All right, now. Let me see if I can pull this up, and I'll talk about it very briefly. Close that. I think I actually have it under calculus. New book. Reference. It's right here. I handed this out to calculus, just going here. Here's last year. Oh, I can stop recording.